Galvanized rigid metal conduit, often abbreviated as GRMC, is a robust type of electrical conduit frequently used in various construction applications. Its primary purpose is to provide a protective pathway for electrical wiring, shielding it from mechanical damage, moisture, and other environmental factors. One common application involves encasing GRMC within concrete structures, which present specific considerations regarding material compatibility and adherence to electrical codes. When GRMC is embedded in concrete, it's crucial to ensure that the conduit's galvanization, typically a zinc coating, is not compromised by the alkaline nature of concrete. The high pH of concrete can react with zinc, leading to corrosion and potentially affecting the conduit's structural integrity and protective capabilities. To mitigate this risk, several strategies are employed. Firstly, using a suitable type of concrete mix is essential. Concrete mixes with lower alkalinity are preferred to minimize the corrosive effects on the galvanized coating. Secondly, applying a protective coating or wrap to the GRMC before encasement can provide an additional barrier against chemical attack. This coating acts as a physical separation between the conduit and the concrete, preventing direct contact and reducing the rate of corrosion. Thirdly, proper installation practices play a crucial role in maintaining the integrity of the GRMC within concrete. This includes ensuring adequate concrete coverage around the conduit to prevent moisture ingress and promoting proper drainage to avoid water accumulation. Fourthly, the National Electrical Code, or NEC, provides guidelines and requirements for the installation of electrical conduits, including those encased in concrete. It's imperative to consult the relevant NEC articles to ensure compliance with these regulations. These articles cover aspects such as conduit sizing, support requirements, and grounding considerations. Fifthly, grounding is a critical aspect of electrical safety when using GRMC. The conduit itself can serve as a grounding conductor, providing a low impedance path for fault currents to return to the source. Proper bonding and grounding techniques must be employed to ensure the effectiveness of the grounding system and minimize the risk of electrical shock. Sixthly, the selection of fittings and connectors used with GRMC is also important. These components should be compatible with the conduit material and suitable for the intended environment. Corrosion-resistant fittings are recommended to prevent deterioration and maintain the integrity of the electrical raceway. Seventhly, regular inspections and maintenance are essential to identify and address any signs of corrosion or damage to the GRMC. Early detection of problems can prevent more significant issues from developing and ensure the continued safe operation of the electrical system. Eighthly, in some regions or specific applications, additional requirements or recommendations may exist regarding the use of GRMC in concrete. Consulting local building codes and industry best practices is advisable to ensure compliance with all applicable regulations. Ninthly, the use of supplementary reinforcing steel or rebar in the concrete structure can also influence the performance of GRMC. The proximity of rebar to the conduit and the electrical conductivity between the two materials should be considered to minimize the risk of corrosion caused by stray currents. Tenthly, proper sealing of conduit ends and penetrations is essential to prevent the ingress of moisture and contaminants into the electrical raceway. Sealants and sealing fittings should be used to create a watertight barrier and protect the wiring from environmental factors. Understanding these various aspects of GRMC encasement in concrete is crucial for ensuring the long-term reliability, safety, and compliance of electrical installations. Consulting with qualified electrical engineers and contractors is recommended to address specific project requirements and ensure adherence to all applicable codes and standards. The National Electrical Code, published by the National Fire Protection Association or NFPA, is a widely adopted standard for safe electrical installations. It provides comprehensive guidelines for various aspects of electrical systems, including the installation of conduits in different environments. Article 300.7 addresses raceways exposed to different temperatures. Article 300.7 it discusses sealing raceways and conduits entering buildings. It focuses on preventing the circulation of warm air to a colder section of the raceway and specifies that an approved sealant should be used. The purpose is to minimize condensation within the raceway. Article 300.7. B covers expansion fittings for raceways. It states that raceways must have expansion fittings if subject to temperature change and expansion. This ensures that the raceway can expand and contract without damaging equipment or structures. Article 300.10 pertains to the mechanical continuity of raceways and cables. Raceways, cable armor, and cable sheaths must be mechanically continuous between cabinets, boxes, and fittings. This provision ensures physical protection and provides a path for grounding. Article 300.11 discusses securing and supporting wiring and cables. Wiring and cables must be securely fastened in place. Raceways must be supported according to the requirements in Article 344.30 for rigid metal conduit, or RNC, Article 352.30 for rigid polyvinyl chloride conduit, or PVC, and other applicable articles. Article 300.12 pertains to raceway and cable runs installed in a complete system. Raceways and cables must form a complete electrical pathway, meaning they must be continuous from one termination point to another. This ensures a safe and reliable electrical system. Article 300.13 discusses the mechanical and electrical continuity of conductors. Conductors must be electrically and mechanically connected to terminals, and splices must be made in approved enclosures. This ensures that the electrical circuit is continuous and safe. Article 300.14 covers the length of free conductors at outlets, junctions, and switch points. Sufficient free conductor length must be provided to allow for easy connections and maintenance. Typically, at least 6 inches of wire should extend from the box opening. Article 300.15 pertains to boxes, conduit bodies, or fittings where conductors are spliced or terminated. A box, conduit body, or fitting must be installed at each conductor splice point, outlet, switch point, or junction point. These enclosures protect the connections and provide a means for accessing them. Article 300.16 addresses raceway seals. Conduits entering enclosures that are required to be explosion-proof or dust ignition-proof must be sealed to prevent the propagation of explosions or dust. Sealing fittings are used for this purpose. Article 300.17 covers the number and size of conductors in raceways. The number of conductors permitted in a raceway is determined by the cross-sectional area of the conductors and the fill percentage allowed by the NEC. The tables in Chapter 9 of the NEC provide guidance on this. Article 300.18 discusses raceways used as pull boxes. Raceways can be used as pull boxes under certain conditions, provided they meet the requirements for size and accessibility. The length of the raceway should not exceed the dimensions specified in the NEC. Article 300.19 pertains to supporting conductors in vertical raceways. Vertical conductors must be supported to prevent their weight from straining the terminations. Various methods, such as cable supports and clamping devices, can be used. Article 300.20 addresses induced currents in metal enclosures or metal raceways. When conductors carrying alternating current are installed in metal enclosures or raceways, induced currents can flow in the metal. These currents can cause heating and voltage drops. Measures should be taken to minimize these effects, such as using non-metallic raceways or bonding the metal enclosure. Article 300.21 covers the spread of fire or products of combustion. Electrical installations must be designed and installed to minimize the spread of fire or products of combustion. Fire-stopping material should be used to seal penetrations through fire-rated walls and floors. Article 300.22 pertains to wiring in ducts used for dust, loose stock, or vapor removal. Wiring is generally not permitted in ducts used for dust, loose stock, or vapor removal. If wiring is necessary, it must be enclosed in rigid metal conduit, intermediate metal conduit, or electrical metallic tubing. Article 300.23 addresses underground installations. Underground wiring must be protected from physical damage and moisture. Direct burial cables must be listed for the purpose, and raceways must be suitable for underground use. Article 300.24 covers the use of raceways as grounding conductors. Metal raceways can be used as grounding conductors, provided they meet the requirements of Article 250. The raceway must be electrically continuous and have low impedance to ground. Article 300.30 pertains to the support of raceways. Raceways must be securely supported to prevent sagging or displacement. The spacing between supports depends on the type of raceway and the size of the conductors. Article 300.31 discusses the securing and supporting of boxes and conduit bodies. Boxes and conduit bodies must be securely fastened to a supporting structure. They should be installed in a manner that prevents them from being damaged or displaced. Article 300.34 addresses the installation of raceways containing conductors of different systems. Raceways containing conductors of different electrical systems, such as power and communications, must be insulated from each other. This prevents the possibility of voltage transfer between the systems. Article 300.35 covers the protection of raceways and cables from physical damage. Raceways and cables must be protected from physical damage, such as impact, abrasion, and crushing. This can be achieved by using suitable enclosures, guards, or barriers. Article 300.37 pertains to the sizing of pull boxes, junction boxes, and conduit bodies. Pull boxes, junction boxes, and conduit bodies must be sized according to the number and size of conductors they contain. The dimensions of the box should be sufficient to allow for easy installation and maintenance of the conductors. Article 300.39 addresses the installation of conductors with other systems. Conductors of different electrical systems, such as power and communications, should be installed in separate raceways or compartments. This prevents the possibility of interference or voltage transfer between the systems. Article 300.40 covers the use of raceways for support. Raceways should not be used as a means of support for other equipment or systems unless they are specifically designed for that purpose. This prevents the raceway from being overloaded or damaged. Article 300.41 pertains to the identification of grounded conductors. Grounded conductors, such as neutral wires, must be identified by a white or grey insulation. This helps to distinguish them from ungrounded conductors, such as hot wires. Article 300.42 addresses the marking of conductors. Conductors must be marked to indicate their voltage and amperage ratings. This helps to ensure that the conductors are used within their specified limits. Article 300.43 covers the use of cable ties and straps. Cable ties and straps should be used to secure and support cables. They should be made of a material that is compatible with the cable insulation and should not damage the cable. Article 300.44 pertains to the protection of conductors from abrasion. Conductors must be protected from abrasion, especially where they pass through metal enclosures or raceways. This can be achieved by using bushings or other protective devices. Article 300.45 addresses the installation of conductors in wet locations. Conductors installed in wet locations must be suitable for the environment and must be protected from moisture. This can be achieved by using waterproof connectors and enclosures. Article 300.46 covers the use of flexible cords and cables. Flexible cords and cables should be used only for specific applications, such as connecting portable equipment. They should not be used as a substitute for permanent wiring. Article 300.47 pertains to the support of luminaires, or light fixtures. Luminaires must be securely supported to prevent them from falling or creating a hazard. The support should be designed to withstand the weight of the luminaire and any additional loads, such as wind or snow. Article 300.48 addresses the installation of electric signs. Electric signs must be installed in accordance with the requirements of Article 600 of the NEC. This includes the use of proper wiring methods, grounding, and overcurrent protection. Article 300.49 covers the installation of data processing systems. Data processing systems must be installed in accordance with the requirements of Article 645 of the NEC. This includes the use of proper wiring methods, grounding, and overcurrent protection. Article 300.50 pertains to the installation of fire alarm systems. Fire alarm systems must be installed in accordance with the requirements of Article 760 of the NEC. This includes the use of proper wiring methods, grounding, and overcurrent protection. Article 300.51 addresses the installation of communication systems. Communication systems must be installed in accordance with the requirements of Article 800 of the NEC. This includes the use of proper wiring methods, grounding, and overcurrent protection. Article 300.52 covers the installation of radio and television equipment. Radio and television equipment must be installed in accordance with the requirements of Article 810 of the NEC. This includes the use of proper wiring methods, grounding, and overcurrent protection. Article 300.53 pertains to the installation of community antenna television, or CATV, systems. CATV systems must be installed in accordance with the requirements of Article 820 of the NEC. This includes the use of proper wiring methods, grounding, and overcurrent protection.